Hello and welcome to the next lesson, Case Study 2, Social Media Platform. Let's get started. Situation is that Alex is a tech entrepreneur who wants to create a simple social media platform to help local communities connect. This platform will allow users in a specific area to share updates, join groups based on their interests, and interact with others in a safe and easy-to-use environment. With limited funding and a small development team, Alex plans to build a minimum viable product, or MVP, first, enabling him to test the idea and gather user feedback. The requirements of the system now. 1. Users can create accounts and log in securely using their email, password, or social media accounts. Each user can customize their profile with their name, bio, and profile picture. Users can follow others and join groups based on shared interests with features for discussions and posts specific to those groups, which will appear on their feed. The platform allows users to create, edit, delete, and comment on posts. And lastly, a content moderation system will automatically filter out inappropriate content based on established rules and guidelines. All right, so now let's go into designing this system. First off, we always start with the user because this is the user that's actually using this service, right? So first, we learned some stuff with case study 1. If we want to have, let's say a website, we're going to need some sort of service that's going to service information to the browser, on your phone or on your computer, so that you can actually see the actual application. So first off, I'm going to put a service here, but I'm going to this time put a service on its own. The reason being is that at this point, again, social media platform, we talked about, and I have the requirements here. We have like bios, like user profiles. We have groups, right? We have comments. There's a number of entities, a number of data that's being saved here, that's being organized. So in such a situation like this, when the data that you're storing is getting more and more complex, you'll still, of course, like the relational database that has this ability to have distinct groups of information like profiles or users, profiles, groups, comments, and to be able to connect them with each other is very good at that, right? But because of the complex relationship between all of these things, sometimes you'll see a lot that they'll have a service dedicated to that in itself. So let me go ahead and let's go ahead and I'm going to start writing some stuff. So I'm going to call this, so this is the independent web service that doesn't have like a relational database attached to it, right? And then, give me 1 second, I'm going to make that here. Then here, there's lots of different words for it, but what I've heard a lot, call it a data layer service. And the idea is that you have this dedicated service that's not seen by the user. It's not like this doesn't serve websites. What it does is provides as a task building block. It provides a series of functions. It could even be an API that and that handles all like the data manipulation or the data access of the database. Like for instance, so instead of the web service saying like, hey, I want to get all the comments for a particular user that like what a particular user made, right? Instead of it having to directly interface with the database itself, it goes in and calls a function in this data layer service, and that function itself handles all of what needs to be done with the data layer, in the database to get that information. So all of a sudden, your whole architecture can interface with this one service in a consistent way. So again, you have this trade-off again. Every time you see a service, is that you have the trade-off is that the positive is you have this one place that's well-defined that gives you the structured way to access your data, right, in this service. The con is that this becomes a single place of failure. If this one service fails, then everybody loses access to the data. But there's ways to mitigate that as well. But nonetheless, it is, you'll see this pattern a lot because it is really important for the database to be consistent with the business rules of your application. So it's good to have the business rules in one place so you can test it, make sure it's okay, and then you can do mechanisms like auto scaling and there's a number of other things that you can do to make sure that this service has higher uptime. So that's why we have this here, okay? okay, it's a social media platform. Of course, you're going to have images. You have this profile picture here, right? So that means we'll need a place to store those images. When what's more efficient to store images, as we know, is it's a raw file service. So let's go ahead and get a service connected to a file store. File store is where those images will be stored, and the service will be where it's accessed. So just like in case study 1, we're going to go ahead and put that here and call this the raw file service. Also, similarly, again, like when people are looking at images and you really want to reduce the load to that raw file service, we want to put a cache in front of that, because images don't typically change. The actual images don't change often. So, and when you have something that's read heavy but don't have a lot of writes, a cache is typically really good. So go ahead and put that there. And then this will be the media, media cache service, just like we had in case study 1. Okay, and then we'll make some connections. Give me 1 second. We'll go switch this to my elbow connector. All right, so service will go to data layer, of course. The service will also go to the raw file service. The media, and then the media cache is connected to raw file cache server, and then as the user gets to the actual web file, right? And if they have an image that needs to be accessed, it can directly access it through this media cache service. A lot of times implemented as a CDN or content delivery network that makes it, have a server that's really close to them so that they can get that image, that media very quickly. And in addition, not taxing the raw file service or the data layer service even. So, so far, except for the web server being its own thing, this is a lot of attributes from case study number 1. Now, another thing to note is that, hold on. Oh, let me just adjust this real quick. Oh, hold on. There we go. So, another thing to note is that, let me just delete this here, is that we have users that have accounts and want to let them to log in securely. Typically, social media platforms are, let's say, they call walled gardens. Walled gardens meaning that in order to get many of the functionality of an actual social media platform, you're going to have to log in. If you think about all the social media applications you use, there's typically a login. So in this case, we want to put that, use authentication service. Let me go ahead and let me move this over here and give myself more space. Let's get that authentication service, which is a service backed by the key value store. Remember, you log in, and then the key value store has the role that you play. Like, let's say user, and maybe have, in this case, an information like ID of this is the user and this is the ID, so that when it goes to the web service and the data layer service, it says, okay, this ID has access, this user of ID 2 has access to all these things. You have that information being populated. So hold on, let's go ahead and name this the authentication service. I'm going to call it Auth service for short, so that we have space for other things. So yeah, you'll still need that, right? So let's go ahead and connect that there. Now this is when it gets interesting. So when a social media platform, again, in our case study 1, we had a web page cache service that cached pages, right? But then if you think about social media usually is a bit more dynamic like that. People are not, at least in many social media platforms now, are not creating a page that everybody sees that doesn't change often. It's usually you see this feed with comments from groups, comments from people, comments from a number of different sources, and you have this ability of users can follow people, you can follow groups, and so on and so forth. So then we still want the ability, because if you just imagine have lots of users with that are making comments and posts, and they have groups and they're following, so on and so forth, we do want to have a way to not tax this data layer service, so that every time a person logs in, it has to get all the information for all the posts that they're following into their feed, right? We don't want that, right? But then we have to think about, okay, so how can we use a cache in this case in this situation? So here's something that's something you can do. let's have that cache, right? Oh, give me 1 second to move things around so I have space. Oh, I'll move this here. Okay. And then let's go ahead and get that key value store, right? So we'll still have our cache, but I'm going to name it something interesting, and we'll talk about it. I'm going to name this feed cache service. Why am I saying that? What I'm saying here is that, and then hold on, I'm going to connect the auth service to the feed cache service, and then connect that to the web service, right? What we're doing here, what I'm saying here is that we're going to cache the feed itself. And what is a feed? If you think about it, lots of different social media applications, you log in as yourself and you have this list of updates. And then with the system requirements, it would be like people that you're following, the posts that they've made, groups that you're following, and the posts they've made. It's basically what would be in this feed. We're going to cache the feed. Now, when I say this, you might just say like, how's that going to work? Because aren't people like creating posts all the time? When you have to update this all the time, wouldn't this have wouldn't this be a tax? This is true. And this is a trade-off we're making, right? We are really trying to avoid, because of all the different comments and posts that people can make, having every user continuously just go to the data layer service and do that will really tax the system. That's something we know, right? If we're putting a cache in front of a blog, that and we think that's a good idea, just imagine the scale for a media platform. Hold on, I wanted to fix this thing a little bit. There we go. Okay, right? So we do want that. So that means is that, okay, what are we willing to do in order to ensure that that's okay, right? Well, we build some systems in place in order to have a cache that can really alleviate that concern. So we take the feed cache service. What the feed cache service will do is that in this key value store, you have the user, and then it will have all of the comments, links, all of the comments, or all of the posts that they're, the users that are following, or groups that they're following, in the cache itself, so that when they see they go to their feed, they go to this feed cache service and doesn't have to get calculated by the data layer service. But then the question is, okay, how do we keep this up to date? Well, this is what we do. One thing that we can do is, there's a number of ways to do things. Always know that that's the cool thing about system design. You'll be surprised. There's so many different ways to do things, right? And what I'm showing you is this building block way of doing it, of things, because the goal is not to just be like, this is the best way to do things. I want you to have that senior level intuition to know that you have these different scenarios, these different systems, but they're built by the same building blocks. And if you understand that, then when you go into the actual technology, which could be very different, if you understand overall what really is happening at a more of a macro level, it gives you that intuition to know, oh, I can use a cache in this situation, I can use a data layer service in that situation. And that is what really gives senior engineers the confidence to face a new application they never built before and build it, because they understand the components and the trade-offs that you can do in order to build the application you want. So that's a little bit of a side. But here I'm introducing this thing I call the time element here, okay? The time element gives this ability to, hey, every so often or scheduled, you can activate something. That's why it's an external entity, because, it's an external entity because something has to trigger it at a certain time, right? A lot of times, this could be like a cron job or so on and so forth, but we're introducing this external entity coupled with a worker. So again, what a worker is a task building block that executes code just like a service, but doesn't have an open port that the user can access or other things can access, right? So it can just be initiated. It's like, think of it as a script or a function that's run, right? So I'm gonna call this the feed cache update service. Why? Because we're going to say in here, every 15 minutes, let's just say here, right? What this is going to do is going to kick off, and it's going to go ahead and connect to this data layer service, okay? That's the first thing it's going to do. And it's for all the different users. And mind you, again, since this worker or even a set of workers is separate from the whole system, this is not taxing system. And every 15 minutes, it goes to the data layer service with one query, gets all of the new posts that has occurred in the system. And then what it does after that is it goes ahead and updates the service. What does this do here, right? And like, let me write this down so that we don't forget. We'll just say, hold on. Triggered, I'll just say every 15 minutes, right? What does this do? So what this does is, this is a trade-off we have. This feed is not necessarily real time anymore. It can be stale every 15 minutes. But with that trade-off, we can generate the trade-off that we have to store in a separate place and take up more space, all of the feeds for all the systems and all the users in the system. But with that trade-off, we can have them when a user goes to their web page, their home page usually, they can get the feed from here and not tax the data layer service. The order of magnitude of access of processing that you just saved the database is tremendous at this point. And you'll see this happen more often than you think, because typically storage is a lot less expensive than tasks and like things that are running. So that's the trade-off that we have here. And also, a lot of times people are not so. Like, you have to think about user expectations here, right? When somebody logs in their feed, if they got a message 5 minutes ago, and they didn't see it, would that be such a large problem? So there's these trade-offs that you have with the user and thinking about your application and some of the things that you're willing to do. I think that so the trade-off of having maybe 10-minute stale posts and comments from their followers is much better than the data layer service going down and they can't see anything. So with these trade-offs, that's why you have this feed cache update service that executes every 15 minutes, that this time element is representing a trigger every 15 minutes for this worker to execute, go and send a query to a message to the data layer service to get them all of the most recent, the last 15-minute comments. It takes those and it updates the cache service with it so that when the user comes, they go and see it. So in this case, a lot of time caches that like, oh, when the user comes, they don't see it here, then they got it from the web service and it gets updated. And that could still happen, but this update service will be the primary way that this cache gets updated. So just note that there's different ways to update. So cool. So you see, we have this system going on so far. Now, so right now we have users can create accounts and log in securely during the auth service. Mind you, also notice that it says social media accounts, but I haven't added anything here, right? There's in truth, what I could do here is that I can say that let's go ahead and add a service here, and I'm going to add this whole external service. What this means is that something that's outside of our system, right, that we want to like interact with. I can do this, and this would be true. I'm going to go ahead and put this here, and let's call this like social account. I should say external social account service. So I can do this, and I'll put this here just to to illustrate that okay, when somebody is like looking to use their external social media account to log in, they'll have to interface with that in order to authenticate. But whether you're using username and password that's in the system or the external social account service, all this will coincide to some key that represents that user, and the password is the credential or the username and password that you have here. And once we verify that either locally with username and password or externally with the social account service, then the value becomes like, oh, this is the user and this is their ID, and then this gets passed all throughout the service. So all the information, all the things that the user does after that will be passed over here, and they'll only get stuff that they have access to, including like what they created with their ID and what they have access to considered their role. So that handles system, requirement one, and then because of that, this customize their profile, the name, bio, and profile picture. That's why we have data layer service and raw file service will have that functionality as well. Users can follow others and join groups based on shared interests. This is why we have this data layer service, because this is getting more complex. All that information and logic will be stored here as well. So and then we have this, users have the ability to create, edit, delete, and comment on posts. This also goes into that data layer service. That's why it's really important for that to have its own thing, because it's being accessed by a number of different functions. But we also have this content moderation aspect that we have to keep in mind here. So what is happening here is that we want to have some moderation to say, like one of the requirements is that we want to have some moderation system that automatically filter out inappropriate content based on established rules and guidelines. There's a few ways to do this, but we're going to do this is going to use some of the earlier forms of AI to do this. So I should say machine learning. But first, in order to do that, actually no, let's talk about that first. So I'm going to put here a service connected to a file store, and I'm going to call that an NLP service. And NLP stands for Natural Language Processing. What is this? So before Gen AI came out, there's been a number of systems. I mean, like machine learning has been out for decades now. And the concept of being able to take words, understand their sentiment, and to be able to make the decision of saying like, oh, this is appropriate, this is not appropriate based on training a model. This has been done. And this is something that we'll employ here. We have a service that access to a file store that has a model, right? Like an actual model, that you're saved there, and it interfaces with that. And the idea is that a comment can go through that, and that can give understanding and sentiment, so that another system can make a determination of saying like, oh, this comment is good or not. How do we do that? Well, we employ a queue, and we'll talk about this in stuff. A queue connected to a worker. So every time a comment, let's say a comment is created, or when we want to moderate, right? We kick off a worker, or maybe we batch them. We can, and have a few at a time. That's something that we can do as well. I'm going to call this, it kicks off, and this content moderation worker takes the comment, runs it through the NLP service, and then has the rules to say like, okay, this is appropriate, this is not inappropriate, and then be able to tell the web service, yes, you can save this, or no, this should be rejected. So therefore, this web service would also be connected to this content moderation worker, and this content worker will be connected to, let's just do it like this. No, there we go, to this NLP service. And so now all of a sudden, oh, this thing looks funky. Give me 1 second to make this look prettier. It's always a little bit of a, one tip using Google Drawing is you could bring things to the front, order to the front, so that you can have those things, more easily connect that over to here. But anyway, little tip for you. So anyway, so we have this web service, comment is created. First, it goes to this content moderation worker. It goes into the queue. When a worker is ready, it picks it up from the queue. Says like, okay, I'm going to run some rules in it. One of the rules is run it to the NLP service, determine if the comment is okay. Then it makes a call. If it's okay, it tells the web server, yes, save it to the data layer service. You're good. If it's not, it rejects it and then return that to the user. And you have the content moderation that's automatic here using an NLP service. Yes, you can also use let's say static rules that you can just employ like regular expressions, and you wouldn't need this NLP service. But I wanted to include that here to note that, hey, everything's not about Gen AI and chatbots and AI agents. There's been lots of machine learning applications for years and decades. And this is how some of these things are implemented. And right now we have it, right? And then, so that's our fifth requirement. And this is our end-to-end system. And you see how all the different aspects from the power of a data layer service and how we did the content moderation worker and the NLP service and this feed cache to supply to ensure that this feed cache is up to date. This is how we can do things from a high level. So let's move on to our takeaways. Our first key takeaway: a service connected to a relational database, used here as a data layer, provides stability and consistency to the access of a database, ensuring the database is accessed and modified in a way consistent with the application's business rules. Very important here because you have to deal with users, you have to deal with profiles, you have to deal with comments, you have to deal with groups in a consistent way. This has become something very important when things get a little bit complex. Second key takeaway: a service connected to a key value store, here a feed cache service, can do more than just store web pages. By pre-processing user feeds, we can reduce the load on the database, though this does use more space. This is the trade-off. To keep this cache current, we set up a worker that runs every 15 minutes to check for new comments. This worker updates the feed cache service to group several comment updates into one cache update, reducing read load to the data layer service and write load to the feed cache service. So that batching becomes a very important part of this. Third key takeaway: a file store connected to a service like our NLP service is helpful for more than just chatbots. Natural language and understanding sentiment are other popular use cases for machine learning models. To prevent the NLP service from getting overwhelmed, we use a queue system that allows workers to process only as many requests as they can handle. This NLP service works with the comment moderation workers to decide if comments are appropriate for our social network. And you're going to see this pattern in later on case studies as well. All right, thank you so much, and I'll see you in the next lesson.